Okay, so a very good morning to all of you once again. So we are in the last chapter of fluids mechanics, which will be the energy losses in pipe. So the objective for this chapter will be to explain the run pipe system, then what type of losses that might occur. Then you should know how to analyze the losses in a pipeline system itself later. Okay, so for today's sessions, as you can see that this will be what we call the Bernoulli equations, right? So Bernoulli equations, previously that you learned that energy in, which will be the point one, will always equals to the energy out. Okay, however, in the real life situation itself, okay, it will uh, will have some losses here, which denotes by the H value. So actually it's H1 minus H, okay, it's H itself equals to the H2. Okay, just to recap the Bernoulli equation. So this one will be what you call the pressure energy, yeah? Pressure energy. Second term will denotes the kinetic energy, and last and for all, the Z value will denotes the potential energy. Okay, so this will be the profile in the circular pipe system. So if you have a laminar flow, so later in your practical task, you will learn regarding a laminar flow, which is a smooth flow. Then you have a turbulent flow, okay, in a spiral form. So if you have a rough pipe and a smooth pipe, that will be the profile velocity of it. Okay, you can see this will, the left hand side will denotes the what you call the laminar flow, and then you have the turbulent flow here. Okay, the velocity profile itself. So today our first equations that you are going to learn will be what you call the losses in pipe. Okay, so in your syllabus here, you will learn regarding three type of the main losses in pipe, which sudden death, sudden sudden enlargement, sudden enlargement. Then you have what we call the contraction, okay, from bigger diameter of the pipeline to the smaller diameter. The enlargement will be the opposite of the after aforementioned. Then you have a friction. For the outlet and inlet, it will be the same as enlargement and contraction later. So I will show to you how do you correlate between the enlargement and contraction with the sharp inlet and outlet. Okay, so the major one will be one enlargement, the contraction, and the friction loss. So today we are going to concentrate on enlargement only. Okay, so this will be the general equations that will be involved. So enlargement. So for enlargement here, we will denote this one by HL. Okay, L for enlargement basically denotes the enlargement. Equals to V in a bracket V1, velocity in pipeline 1, okay, minus V2, V2 in the larger pipeline, larger diameter pipeline. In bracket square over 2G, that will be the equation that will be involved. Okay, so we just, for these sessions, you just concentrate on the first one. Okay, so we are going to have a look on the examples of usage of enlargement equations here. So I will guide you through this. Okay, so if you have a pipeline carrying 1,800 liter over minute water, okay, so it suddenly increase the pipeline diameter increase from 10 centimeter to 15 centimeter in the diameter form. So your first task will be to calculate the head loss due to sudden enlargement. Okay, and second one, you are going to utilize the Bernoulli equations, which we try to obtain the difference in pressure. So answer should be in kilonewton over meter squared for these two pipeline itself. Okay, so I give you a minute for you to digest the informations here. So you can see in your questions, there will be 1,800 liter over minute. So what is that? So that one is volume over time. It's a volume. Liter is a volume. So minutes will be the time. So from here, you actually learn regarding Q. Q. Okay, Q will be what we denote as
Flow rate.
flow rate. Good. So flow rate will be volume over time. So over here, actually, you need to convert. You need to convert to the SI unit, which will be meter cube over a second. Okay. So in order for you to do conversions, you need to know how to convert liter to volume, minutes to the second. Okay. So liter convert to meter cube. This one, maybe you need to write this one down. It's quite a popular questions here. Normally, they will give you in liter. So they might require you to convert to meter cube. But you will be divided by 1,000. You need to divide by 1,000. Okay, then for minutes to the second, so you know that 1 minute consists of how many seconds?
60.
60 seconds, right? Okay, so hence, you will be able to obtain the Q value here. So what is your answer, please? You need to 1,800 divided by 1,000, you get 1.8 there, right? Then you divide by 60 again. Okay, therefore, you should get 0.03. Okay, so the Q, the flow rate for this system will be 0.03 with the cube of a seconds. So there will be only one equation that you learn regarding Q, which will be Q equals to AV, right? Okay, from the previous chapter. Hence, for you to insert V1 and V2, sorry, here it will be V2 actually. V1 and V2 here. So you need to obtain the velocity first, V1 and V2. Okay, therefore, using Q, you already know the value of Q, right? So QAV, so V will equals to Q over A. Okay, so please try to get the area A1 and A2 first. A1 diameter.
Centimeter.
You put in 10 or 15 actually. It's an enlargement. So A.1 will be
15.
0.1 should be 10, 10. Because enlarge, right? Enlarge. So from 10 to 15, only enlargement. So 0.1 is the smaller pipeline here. So you can see here. Okay, here, right? 0.1. Can you see the PDF?
Yes, sir.
Yeah, okay, 0.1 and 0.2. So when you do contraction later, it will be versa, opposite. One will be at the larger, then it will shrink, right? 0.2 will be here. Okay, so go back to here. So 0.1 here, please insert 10 cm. Cm is over 100. So 0.2 is 50. Okay, please try to come up with area 1 and area 2. Okay, so if you calculate it correctly, A1, you're supposed to have 7.8540 times 10 power of negative 3 meter square, and A2 value will be 0.0177. meter squared. Okay, so hopefully that value is the correct one. Okay, then you are going to utilize Q equals to AV, the previous equations that you have learned. So in order for you to obtain the velocity, okay, you have Q over A. Okay, so your Q value will be 0.03 for both 1 and 2, right? Because it will remain the same within the system. So you're going to divide by this A1 value here. Okay, A1 value. And we have A2 is this value itself. Okay, let's try to come up with the V1 answer. Okay, so V1, you obtain 3.8197 meter per second, and then you have V2 1.6949 meter over second. Okay, therefore, for the losses due to enlargement, you need to write down the main equations, okay? So before we insert the V1 value, it should be 3.8187. And we have V2 value 1.6949 here. Okay, so square over 2 times with the gravity over 2 times with 2 times with gravity 9.81. Okay, so try to obtain HL, losses due to enlargement. Okay, so once you insert all the value, then you calculate it, you're supposed to have the losses equals to 0.2301 meter. It will be in a meter form. Okay. Then we move to the second section. So they would like you to calculate the difference in pressure. So answer should be in kilonewton over meter square. Okay. So as I mentioned previously, you need to correlate, okay, the losses here with the energy in and energy out. Okay, the Bernoulli equations. So the equations here will be to obtain P1 minus P2. Okay, P1 minus P2. Hence, okay, you are going to rearrange this pressure energy in the left-hand side. Then you gather the rest of the terms to the right-hand side. So once you rearrange, it will be in such form. Okay, so please pay attention to the potential energy. Okay, Z2 minus Z1. Since in your questions here, it doesn't stated that you have any inclined angles and so on, right? So we will assume this pipeline will be in the horizontal form. Okay, it will be in the horizontal form. Okay, therefore, it will equals to 0 here. Okay, it will be equals to 0 here. Okay, so hopefully you are clear of this. So in order for us to get the pressure of difference here, the W here, specific weight, we are going to multiply with it, the whole terms on the right hand side. Okay, so I'm going to insert all the value that I have in the current situation. 1.6949 here, I have it. 3.8197. Okay, so this one is a HL value. I will use yours, 2.2301. Okay, then you have your W, specific weight for the water here. Okay, specific weight for water. So hopefully it's not 1000. 1000 is the density for water. So you need to multiply by 9.81. in order for you to obtain the specific weight for the water. Okay, so please calculate and see what's your answer for P1 minus P2. You should obtain negative 3601.43 Newton over meter square. Okay, then they will require you to just put in your answer in kilo, so it's very direct, will be negative 3.60143. That will be the final answer.
Screen macam crash saya. Tak nampak
Yeah.
apa. Screen.
You don't see anything, is it?
No, sir.
Ya. Oh, nampak.
Okay, maybe I stop sharing. Not sure why the current. Okay. Is it okay now?
Yes, sir.
Ya, okey saya.
Okay. So negative 3.60143 kilonewton over meter square lah. That will be the final answer for this. So if you obtain negative value for pressure or any differences, don't be too panic itself. If we obtain negative value, means P2 pressure is greater than P1. That's the only indicator. Okay, so if you rearrange this equation to be P2 minus P1, then you will obtain the same value here, figure here, but it's a positive value. Okay, so don't be too panicked by itself.